Hello and welcome to Cuppa with a Scientist, a podcast by Loughborough University that will interview a different scientist each episode about their academic journey to the top. We will discuss how they went from a confused teenager choosing A-level or equivalent subjects to a leader in their field, with plenty of weird and wonderful stories in between and golden nuggets of advice for those aspiring to get into science. As well as keeping your ears and brain entertained, we hope this podcast will dispel the myth that all scientists wear white lab coats and give you an insight into how vast the world of science really is. And because the makers of the show are painfully British, we'll be doing it all over a good cuppa. So stick the kettle on and settle in. Before we get stuck into this episode, a quick bit about your host. I'm Meg and I'm a PR and Communications Officer at Loughborough University, and I'm also an aspiring scientist. I made the tough decision to return to university 2 years ago to pursue my love of biology, and I found podcasts to be an incredibly helpful resource when making this decision, though slightly field specific. From health sciences to social sciences, we'll cover it all in this podcast and show you how vast science really is. And hopefully you'll pick up a few tips and tricks along the way to help you on your journey to becoming a scientist. Joining us for today's episode is Professor Rob Wilby, a Professor of Hydroclimatic Modelling in Loughborough University's School of Social Sciences and Humanities. Rob's research looks at the management of fresh water and urban environments under climate change, and this spans reconstruction of drought and flood indices to assess the severity of recent extreme events, through to detailed monitoring of river temperatures for ecological purposes. His latest research is exploring smarter approaches to climate risk assessment and decision-making under deep uncertainty about the future climate, but more on all of that later. So hi Rob, welcome to the show. We're thrilled to have you on. Most important question, what mug have you gone for today and what's in it?
So this is my climate risk mug, which is eagerly sought after. Only those people who've actually helped with the National Climate Change Risk Assessment qualify for one of these. So I imagine these will become a collector's item in due course. And there's a nice Americano inside.
Fabulous. Mine's not as impressive. Yours is kind of an exclusive mug. Mine's anybody can buy it off the shelf. But we've gone for BB-8 from Star Wars today. And I wish every time I do this podcast, I wish I could say I have a fancy coffee, but I don't like coffee. So I've got an energy drink, which is full of chemicals, and we'll just pretend it's not that. And we've also asked you to bring an artifact with you. So have you brought something with you today?
I've actually cheated and I've gone for 2 artifacts. So this is my first one, which is a piece of bleached coral. In some ways, it's a sad thing to show because this is a sign of our times, that our great coral reefs around the world are literally dying on their feet. And this piece of coral was washed up on a beach in Malaysia. I staggered on shore, having been caught on a really nasty storm, and just found this big chunk of coral lying on the beach alongside lots of other corals. So that's my first little item. Second one is a device called a tiny tag. And this is a really clever piece of equipment. We can put it in a river, we can put it in a room, and we can measure temperature at very high resolutions for up to a year at a time, and it gives us really detailed information about how temperatures are changing in a particular environment. I'll probably speak about that later.
Fantastic, thank you for bringing those. They're 2 very different but very interesting artifacts, so thank you for that. So let's get into it. So you're a Professor of Hydroclimatic Modelling. Can you explain what that means, please?
Yeah, I accept that's a bit of a mouthful, and I always have to explain to people. So essentially, climate and water go hand in hand, and what I research is the interactions between climate and water. And I also study water in 3 main ways: when we have too much, too little, or too dirty water. And the drivers, the causes of all of those 3 conditions are essentially climatically driven. And this has been the root of a great deal of my research over the last few decades.
I think that's a good kind of breakdown of what it is. Why specifically is this an important area of research?
Well, climate and water do go hand in hand, as I said, because water in the atmosphere is, in a sense, a greenhouse gas in its own right. The more water vapor that goes into the atmosphere, the more the atmosphere will warm up, and will also be able to throw heavy amounts of water in downpours, in storms, and cause flash floods. And also, of course, when we have too little water in the shape of droughts driven by climate change, then that's a big problem for us as well. So climate and water really do go hand in hand. And by studying them alongside each other, we get different types of insight into how these will play out in the future.
Got you, thank you. So say you're at a dinner party and you tell people your job title. Is there any kind of common misconceptions that people seem to have? Do they ask you some kind of repeating questions that just aren't related to your work?
Actually, I'm remembering a question I was asked at a friend's wedding reception a few years ago. Someone came up to me and said, "Rob, what's the difference between rainfall and precipitation?" So that's the kind of teasing I get. What do you boffins do during the day to study the weather? Something we all feel and encounter on a daily basis. So I do get quite a bit of teasing about it.
I like that, Dr. Weather. Brilliant. So we're going to discuss a bit later about your research now and kind of the applications of that. But first I want to take it back a little bit. So I can't imagine young Rob, 5 years old, said, when I grow up, I want to be a professor of hydroclimatic modelling. I mean, correct me if I'm wrong. But what did you want to be when you were younger? I'm trying to figure out how we've got to where we are today.
Well, actually, one of my very earliest memories was being woken up. I think I was probably about 4 years old by an extremely violent storm in the middle of the night. And I think my dad knew I was awake and perhaps a bit scared. And he came and sat down next to me and we just watched the storm at night as it played out. And he explained to me what was going on, what was causing the storm, what was causing the lightning strikes. That gave me a really deep fascination for extreme weather from a very young age. And then as a teenager, I actually wanted to follow in the footsteps of my grandfather, who served in the Royal Air Force as an aerial photographer. And that took him all over the world and allowed him to view from above some absolutely incredible landscapes. And I thought that sounds like a fun thing to do. Sadly, my eye-hand coordination is absolutely rubbish, as you can probably tell from the gesticulation here. And so I didn't make it to be a pilot in the RAF. So I had to revert to plan B, which was to be a geographer and to explore the world and to think about some of the great issues and challenges of our day. And that's really brought me to the subject that I really dearly love and have worked in for the last 30 years.
I never knew about the potential of the career. So did you try out for that career and then did you end up going back into A-level? Or I'm just trying to work out if you kind of came back as a mature student, or because I think for listeners, it's really good for them to hear how the path isn't always straight and it's a bit winding. So if you could tell us a bit more about that, that'd be great.
Well, mine was certainly not a straight path. So my career is quite an unusual one. I've meandered in and out of academia. So my very first job was actually in a water company. And then I moved into a lectureship and then some overseas research. I worked for the Environment Agency for several years, came back to academia after a spell as a consultant. And this is here and now. I've been in this present role for about just over a decade now, but very much meandering between the world of water in action, in industry, in government, and in research and in consulting. So the central theme that's run all the way through that is how can we put very best science into practice? And that's something I've been trying to figure out my entire career.
So what A levels did you study and which university did you go to and what did you do when you arrived there?
So I did geography, maths and physics. So I've always loved crunching numbers, which is a very useful skill to have if you're into climate change and studying the impacts of climate change and how to manage climate change. And as a teenager, I was also a very keen runner. And the combination of freshwater science, and climate and running actually brought me to Loughborough University. So I studied here as an undergraduate in the 1980s. I did my PhD here, but then I spent, as I've explained, many years away exploring the world and other career options before I came full circle to where it all began.
And how long have you been back at Loughborough in the position that you are now?
I came back here in 2008, so 13 years. In fact, this is the longest I've stayed in any job. So that
congratulations! I have to get a cake for that. So we've just kind of given an overview of quite a journey spanning a fair few years. You must have collected some kind of fun career stories along the way, maybe some standout field trips or anything. Is there anything you can share with us?
Yeah, I mean, I've worked in some really amazing parts of the world, and in some cases quite scary parts of the world, and I've had a few scrapes along the way. But one that stands out for me is when I managed to lose my passport on my first trip to Tajikistan in Central Asia. And it had dropped out of my pocket while I was out for an evening meal. And thankfully, the locals were kind enough to put out a message over the city radio to say that this Brit had lost his passport. Could you hand it in if you find it? And sure enough, 2 days later, someone handed the passport back to me, all intact and all was good. But you can imagine the panic mode I was going through as I was beginning to think, well, how do I get back from Tajikistan to home without a passport?
Oh, crikey, that's my worst nightmare. I check again every time I go anywhere. So have there been any kind of low points in your career where you kind of questioned if this is the career for you, or have you faced any difficulties?
Well, I think most academics and researchers have to be able to deal with a lot of rejection. So we write research papers that can sometimes be rejected. We write grants, proposals that can be rejected. We might apply for jobs and get rejected like everyone else. So being resilient to rejection and picking yourself up and learning from those experiences is an important part of staying the course as a researcher for many decades. So if we got pushed down by every rejection of a paper, I would have bailed out of this career a long time ago. So I think that's one area. And the other area, I think, in my mid-30s, as the climate change issue was really coming to light, that actually preyed on my mind quite a lot. You know, just the scale of the challenge and what we can and can't do about it. And I think, you know, that did affect me in terms of, you know, it's hard to be cheerful with all of that going on in the background as your day job. But as I've grown through that, I realized that it's much healthier and better to focus on the solutions, to be focused on how can we use science to solve some of these really big problems and issues that lie ahead.
I think that's some really interesting insight, because I know rejection can be a big thing in the academic sphere. And yeah, like you said, I think science, it's often looking at solving some really difficult situations, but seeing the positives, you know, helps you power through that. So been at Loughborough University for 13 years in this position. What does your day-to-day or typical month look like at the university? Is there a typical month, or is it very varied?
There is no such thing as a typical day as a academic at Loughborough. So, for example, today the mix has involved meeting with students, planning for teaching, reviewing the proofs of a research paper, and making some preparations for COP, which is coming up shortly. So, and that's just so far. And of course, speaking with you right now. So, one of the big beauties of the job is the day-to-day variety.
And talking of COP, what kind of preparations are you doing for that?
Well, I've been invited to join a panel discussion as part of, there's a Mexican university that are running a series of seminars, and I've joined that. I've already given a pre-recorded talk and we'll be joining an open panel discussion during the event, which is always a bit of a white knuckle ride because you never know exactly what kinds of questions are going to come towards you.
Do you think, in your expert opinion, is kind of COP26 one to watch?
I think that we are now within a critical decade. This decade really matters for what will come in the future. COP is part of a continuum of negotiations, of advance in scientific understanding, and of determination to address what many are beginning to realize is an immense challenge ahead. But I certainly think we're at the start of a critical decade.
And in terms of kind of your specific research area, what kind of challenges do you think we face in terms of kind of weather, water, and what would you like to see happen potentially at COP in terms of agreements around that theme?
Well, as a water guy, I look at climate change through a water lens, as I've already explained. So the kind of things that I'm most concerned about are what happens to the great snow and ice stores of the world. Some have called them the water towers of the world. So you think of the huge stores of snow and ice in the Himalayas, which sustain the livelihoods, the energy, the crops, and everything downstream for literally billions of people. And those snow and ice stores are some of them are in a very fragile state, and we're not quite sure how that's going to play out, but it clearly has massive implications for many people. Likewise, in our part of the world, we're extraordinarily vulnerable to extreme drought. So the risk of more severe and longer lasting droughts is something that we really have to confront and start planning for. So I think those would be the two things that I would really single out. And of course, here in the West, we benefit from huge amounts of investment in science and monitoring and data sets, which are sadly lacking in many parts of the world, which are right on the front line of climate change, where there's huge gaps in knowledge and information, even about what's going on at the present time.
So thank you for sharing your kind of insights into some of the topics at COP that fit with your expertise. I think this is a good transition now to talk about your specific research areas. So one of your research areas, and I'm going to read this because I know I'll get it wrong, reconstruction of drought and flood indices to assess the severity of recent extreme events. So can you break that down, please, and let us know what that means and why it's important?
Thanks. I mean, in everyday language, that means essentially trying to place modern day extreme weather events in a longer term context. So, of course, the media, it gravitates a lot to extreme flood events and drought. But often we're wanting to understand, just how severe, how extraordinary is this event if we look at it in terms of the last decade or the last century or even longer. So we can use a range of data sets to try and place present extreme events within a much longer context. And this is important because it helps us understand whether or not these extreme events are changing in terms of their frequency, their severity, and their duration. So it gives us a sense of the direction of travel. And it can also help us understand if there are new types of extreme events that are beginning to emerge. So, for example, compound events where you might have, for example, very severe flooding combined with a very severe storm surge affecting coastal communities on a scale that hasn't been seen before. Or you might have combinations of, for example, a tropical cyclone followed by an extreme heat wave, which would cause a lot of harm to people that depend on air conditioning. So studying the present extremes in this longer term context is really important.
And with climate change, if we carry on the way we are, what do you expect to see happen with these extreme events and the compound weather hazards that you just mentioned?
Well, I think, there's a lot in the media already, isn't there, about how we expect heat waves to become more extreme, more commonplace, especially within the tropics, but also closer to home. We see recently some extraordinary flood events across Europe and the tragic consequences of that. Now, of course, these sorts of extreme events have always happened, so we have to be very careful to not blame everything on climate change. But the fact is that by changing the climate, we are likely increasing the chance of these events that always happen, but are likely to become more commonplace and more severe in the future.
And this kind of leads me on to another project that you're working on. So I know you're involved with something called Flood Map Live. Could you kind of give an overview about this and explain how you're involved with this as well, please?
Well, this is a piece of work that has developed from a research collaboration with my colleague Depeng Yu, who takes information about future heavy rainfall patterns and plugs them into very detailed models of urban surfaces, of streets and cities. And when you take those two ingredients and you bring them together, you can produce super fine resolution maps of flooding, literally at the street level. And you can do that several hours ahead. So that information can be provided to emergency responders. It can be provided to the general public ultimately, so they're able to move just simple things like moving a car out of harm's way if you've been warned that this particular street is going to flood in a few hours' time. So that ability to give foresight but also fine resolution is a very clever mix.
Fantastic bit of tech. I don't know, tech is the word, project, but yeah, fantastic. So another one of your research areas is monitoring river temperatures for ecological purpose. Could you again break down what that kind of means, please?
Okay, so that brings me back to this little fella, the tiny tag, where we installed a large number of these in rivers in the Peak District to monitor the local controls of water temperature. So, for example, the occurrence of springs, the amount of tree and shade, the effect of the landscape on the water temperatures. And we want to do that to understand ultimately how those temperatures vary in space and how they're changing over time as well with global warming, and also to evaluate how measures might affect temperatures. So one measure we might take to protect fish and other animals in the water would be to plant more trees along riverbanks. So we are using this information to determine how much the river might cool for a given amount of planting. And that's a very useful rule of thumb that you can then give to river managers and land managers deciding where and how much to plant to achieve a given benefit to the river ecosystem.
Oh, I don't think I realised that your research kind of falls into it. A little bit of conservation as well there, helping the fish. I like that.
That's it.
And another area that was listed on your research profile, again, I'll read this to make sure I get it right. Statistical Downscaling Model, or SDSM. And this is a tool you helped co-develop. So yeah, if you could tell us a bit more about this tool, that would be great.
Well, just like with the localized river flooding, having that information where we are, at the street level or at a very localized scale, is what people want to know about the future. So Chris Dawson in computer science and I developed this tool about 20 years ago, which takes very large scale information about climate change from the global models and brings them down in scale, right down to very localized situations. So it might be for an individual river, a city or a field, at the scale where people want to have the information about how and where the climate might change. And we deliberately designed this system to be low tech. So it has very low computing requirements, very low data requirements, which means it can be used by anyone anyone anywhere in the world. And that's really opened up a huge amount of interest in this tool over the last 20 years.
So the tool's been around for 20 years. Have you seen any kind of success stories as a result of using this tool?
Well, people use it in all sorts of different ways. They might use it, for example, to figure out how local rainfall or temperature might change. They might use it to figure out how future river flows might change, and other sorts of variables like that. And we've seen those analyses appear in various government level documents that nations have submitted as part of their planning for climate change. So the tool has sort of wiggled its way into some quite high level documents over the years.
That's really cool. You must be thrilled to see it kind of being used in this way.
Well, yeah, I mean, it was initially intended as a teaching device. I was asked to run a workshop in Canada to train people in the creation of local climate change scenarios. And I thought, rather than just talk to people about this, why not develop a simple tool that takes them step by step through the process in this workshop? And we've not really looked back since then. It's been really incredible the amount of attention and enthusiasm people have had for this tool over the years.
That's brilliant, really brilliant. So your latest research explores smarter approaches to climate risk assessment and decision making under deep uncertainty about the future climate. Can you tell me again a bit more about what this line means?
I'm picking up a theme here as I need to use simpler language to explain what I do on a day-to-day basis, don't I? But essentially, in my view, I think a lot of thinking about what to do about climate change has been bogged down by the fear of uncertainty. The future is so uncertain. That's just a fact of life. And if you embrace that uncertainty and say, the future is uncertain, but what smart things can we still do to help in the future, regardless of uncertainty about climate change? So you start with thinking about the possible, thinking about, okay, we could develop better flood forecasting systems to help people take evasive action, or we could develop better drought forecasting systems. And that technology and that ability to see into the future, even a few hours or weeks or seasons ahead, is still going to be powerful in the future, just as it is today. That's an example of a smart technology, something that you're not going to regret doing, because forecasting is always going to be part of the toolkit for adapting to climate change.
So I know one of the forecasting projects that you're doing looks at extreme indoor temperatures and how you can kind of take action now to help those communities. Can you tell me a bit more about this project, please? And I know you've been kind of overseas doing the work. So if you could tell us how it was experiencing that yourself, that would be great.
Yeah, so this is a project led by Kate Goff, also in the geography department, where we've been looking at extreme temperatures inside people's homes and workplaces in Ghana as a first step. So again, using the tiny tag to monitor those temperatures in a large number of homes and workplaces as the first step. And then the second step is to then help communities identify affordable measures for managing those very high temperatures. What if we change the design of the roof to have more shade? If we improve ventilation, if we make the roof more reflective, how might we use vegetation and shade in the urban environment? So these are all the sorts of questions that we've been exploring. But having gone through and done this field work on the ground, I've encountered some really extraordinary temperatures in people's homes. So the record temperature here in the UK is around 38, 39 degrees Celsius, which would just be fairly commonplace in some people's homes in Ghana. And indeed, we've seen temperatures into the mid 40s degrees Celsius in a home. And so once again, I'm emphasizing the fact that the tropics, in terms of humid heat, and its impact on people's health and livelihoods, that's where the front line of climate change really is.
So are there any other research projects that you're working on currently that we've not covered that are kind of worth talking about?
Well, I'm involved in a project where I'm trying to develop a national water temperature indicator. So essentially one number to capture the complexity and the long-term change in water temperatures across different types of river in the UK. So an indicator that can be used by water companies and agencies and government departments to monitor how this really important variable is changing through time. You might think, well, Rob, how hard can that be? Actually, it's really hard to do because water temperature data sets are fragmented. There's lots of sites where we're measuring temperatures in rivers and other water bodies in different ways, in different times. The records begin and end, and somehow we have to take that patchwork and stitch it all together in a way that we can treat that very large amount of data, millions of data points, in a consistent way to produce a nice, straightforward index, which importantly we can continue to measure into the future to track climate change.
So that would be the purpose of it, just to track climate change and understand how it's affecting our water systems. Could it also be used as kind of a prompt for action? I'm just trying to better understand the applications that it could go to.
Yeah, absolutely. So an indicator like that can be used to show that the environment is changing, but it can also be, so it can be used as an alarm system if things are approaching critical levels for certain species or in certain places. But it can also be used as a way of seeing how effective your interventions are. So if you've got control sites or sites where you're not taking measures and you're monitoring them at the same time, and you're comparing them with where you're taking the action, comparing the two, you can see the effect of the intervention. So for example, planting trees, what has been the benefit to the river of planting the trees compared with not planting the trees? That's an example of how you might use an index.
Got you. So it sounds like it could be a tool that can really help establish what's best practice and then kind of put these measures into place. So what stage are you at with that then? How's it going?
I've been doing some of the preliminary analysis again with a colleague, Matt Johnson at Nottingham University, and we've identified our favourite sites around England, which have the best combination of length and quality and responsiveness to the environment. So we've got our short list of preferred sites, and now we're just trying to see whether or not those sites are going to be monitored into the future, and if not, if there's a site nearby where we can connect to and again stitch together in a careful way.
Well, please do keep us updated on that. Sounds very exciting. And you've piqued my interest now. What's your favourite UK body of water then, if you have a favourite site?
Oh, I'd have to say the River Mole, which is close to where I grew up. And because there are some lovely stepping stones where, as a kid, you can sort of hop over the stones and also paddle around in the shallows of the water, and that brings back very fond childhood memories.
Are you one of these people when you go on holiday, you're just drawn to the river? You're like, got to go to the river, waterfall, any body of water?
Yeah, sorry. I'd like that. I love walking by rivers. I love walking by the coast. I can't get away from water on holiday.
Okay, so we've kind of covered that your job's very varied. There's field work and travel involved. But what is your favourite thing about your job?
I think that's actually changed through time. So when I started off as a young researcher, it was the sheer thrill and enjoyment of getting that acceptance letter. And I note the word letter, not email, through the post, telling you that your research paper had been accepted for publication. And that's something that still gives me a thrill today. It never gets tired. But as I've got older and through my career, I take far more satisfaction in the success and the achievements of my students. When you see them progressing through their degrees, securing fulfilling jobs, and then, you know, really making their mark on the world in terms of solving some of the problems that I've been talking about. For me, that is the ultimate satisfaction.
That's really nice. It's an extension of your success and career, which I like. Are there any not so glamorous parts of the job? So I know we kind of spoke earlier about the difficulties, but a lot of academics I spoke to always say admin. They have a bit of a groan at the admin bit, and being out in the field when it's freezing cold or horrible conditions. So just curious to see what yours are.
Well, I'm actually going to give a kind of a scientific spin on this. So
okay.
An important part of being a scientist is building as large a data set as you can to describe the phenomenon of interest. And sometimes that can involve really monotonous repeat sampling or weighing of things in a lab, or repeat measurements of water quality in this, that, and the other. So repetitive tasks that are needed in order to build statistical rigor or a large data set can be a bit tedious, but it's an absolutely essential part of the job.
It's all worth it when you get those very strong findings and that paper published.
Yeah.
Brilliant. So what is the weirdest thing you've had to do as part of your career?
I'd say, and this takes me back to my undergraduate dissertation, where I had this crazy idea that I could take Polo mints and then hang them in a river, and then they would dissolve at a given rate depending how fast the river's flowing. So I set up all these Polos in the lab with controlled rates of flow to calibrate this simple relationship. And then I took these devices, which were essentially stakes with Polos hanging from them, and put them in rivers, and then weighed the Polos after a given amount of time and could tell how much Polo had been lost and therefore the average flow of the river. So I think that's probably the craziest thing I've done.
I did not expect you to say that. That's fantastic. What did you conclude from your Polo experiment?
It does actually work. I mean, it's
right.
a bit of a messy way of measuring river flow, but it does actually work.
I want you to send me a published paper one day where your methodology mentions that the equipment you need, pack of Polos.
Sadly, it didn't make it from the dissertation, which is still on the shelf somewhere, into published work. But there you go.
You need to get a sponsorship by Polo now. I think that's that's the way to go. So your career, like you said, you've dipped in and out. You're back at Loughborough. You've been in this position for over a decade. It's a long time doing academic research. So what keeps you driven? Do the same things that were driving you initially still drive you now? Just trying to think how you get motivated.
I think, we're all very aware from the news and the media of just the range of issues that face us at this point in time. So there's no shortage of really big environmental issues, and just to be a tiny cog, a piece in the community that is working hard to think out and devise ways of managing these risks in the future, that again is an incredibly fulfilling thing to do. And I'd encourage anyone listening to this podcast, if you're concerned about the future, the environment, people's welfare, their livelihoods, their security of natural resources, the state of wildlife, there is just a huge amount to be done, and you can pick any one of those areas and make your mark in it.
I think that's really good advice, and I think that's part of the reason I went back. I wanted to make a change, even if it's a teeny tiny part of a bigger picture. I just want to do something. So I'm glad to hear that's kind of replicated across the board. So you've achieved a lot in your career, and it sounds like there's lots more going to be coming soon as well. But do you still have like a dream or a specific goal that you've not achieved yet that you'd really like to?
It sounds really corny, but I've been blessed by the fact that I've been able to do much of what I hope to do as that teenager, undergraduate starting out in this line of work. I think there's still some really big research questions to be tackled that we've talked about already, and I'd like to be part of that. But also, I'm really deeply concerned about the people and the communities that live on the front line of climate change, and it's such a humbling thing to be working alongside and with those people, and that is something that I'd really like to continue doing in the future.
So just carrying on, working hard, seeing that where that takes you. That's nice. So what does a professor in hydroclimatic modelling do in their spare time? Do you have any fun hobbies? Are you still running?
Well, I classify myself as a damaged runner these days. So I do a bit of cycling. I like going to the gym. But of course, above all, I like walking beside rivers with my dog.
Brilliant. What dog have you got?
An aged Labrador.
Oh, fabulous. What's her name?
Sophie.
Sophie. We're a big fan of dogs on this podcast, so the more dog chat we can have, the better.
She was 14 a week or so ago, and she still loves tearing up parcels, and her tail's wagging away as she's opening up her parcels. So.
Oh, fabulous age for a Labrador. Really good. So what's next for you in your research? So obviously you're developing what we spoke about earlier, you've got some of the projects. Is there anything else that is kind of coming in the immediate future?
No, I think those things are going to keep me pretty busy. I think also as you go through your career, we've talked about this a bit, that more and more people actually come and seek your advice, and that's very rewarding as well. So whether it's in terms of supervising students or providing advice to research committees or to people who are making really big investment decisions about climate change. And I think that's something I would like to be doing more of in the coming years.
You didn't include people seeking you from the PR team and pestering you to do media work, which I know you love.
Isn't it?
And talking of that, I think that's, I've asked a few people this before, but I think most people starting out in academia don't necessarily realise the importance of media and engaging with the media. And I know it's something you've done frequently. Is that something you enjoy? What kind of value do you see to kind of public science communication?
I see that as a really important part of my job, being able to communicate complex science. And we've given examples today of even the language that scientists use is not often very helpful. So explaining our science, why it matters, how it's hopefully making a difference is a really important thing to do. And that can be everything from meeting communities in village halls on a rainy winter's evening and giving a slideshow, through to talking like now, through to big keynote lectures, speaking to other types of audience which might be non-academic. So it's very varied in its shapes and forms, but it's an essential part of the job. And
hopefully you enjoy some of it. So what areas do you think will be the hot topics for kind of students that are set to follow in your footsteps into this kind of climate research area?
Well, I think I mentioned some of them already around future droughts, future flooding. And as I say, I'm going to be looking at the world through that biased water worldview. But I really think, water is such a profound resource for everything that we need, and how climate change will moderate the amount and the quality of water around the world is a really, really, really important issue, and it's one that affects every country and every community in some shape or form. It's a vast research agenda with lots of really big questions still to be tackled.
So do you have any words of wisdom for students aspiring to be in a position like yours, in a career, well, research field like yours?
I think I go back to one of my earlier remarks, which was the need to be resilient to rejection. You know, we all encounter rejection in different ways in our lives, and, you know, professionally, and being able to cope with rejection professionally, thinking about how can I learn from this experience? How can I make that research paper or grant proposal better? How can I give a better interview next time I'm being talked to on the TV? How do we do these things? You know, that's all about a lifelong learning process, but being resilient to rejection, not staying down for a long time, bouncing back and thinking, okay, that didn't work, I'll try something different.
Do you think as well that with having the resilience, it needs to be paired with having like a real deep passion and belief in what you're doing? Because I can imagine the first rejection makes you question everything. What am I doing? Am I on the right path? Is this worth doing? So do you think having that passion and care is key as well?
Absolutely, yeah. Having that set of core values as to why you're doing this. You know, it's not, we talked a lot about the how to do the research, but it's, you know, why am I doing this research? You know, what is your deep motivation? Is it that you want to be in a little way part of the solution set, and that can be a really very, very strong motivator and help sustain you through the ups and downs, and that's the reality of being a researcher, just like in any other career.
So one of the final questions, why should people consider a career in environmental sciences?
Well, I think just turn on the TV, look on your social media, read the papers. There is just a huge amount to do in terms of the social and environmental challenges that lie ahead. And I use the words social and environmental because we've got to look at those together, environment with people. And there's so many areas in which a young researcher can apply his or herself into those problems, and we don't have to look very far to find something that will chime with our own particular skill set, our own motivation, and our own pathway as well. As I'm thinking back to that experience of watching the lightning storm as a 4-year-old.
And I'm going to put you on the spot with this final question. If you had to describe your career in 3 words, only 3, what would they be? I told you I was putting you on the spot.
That's a really hard question. 3 words. I'd want to go for 2, I suppose. Crazy journey.
Oh, nice. Fabulous. I like that.
Crazy journey. And by crazy, I mean, you know, not crazy, but as in having all sorts of unexpected happenings and joys and thrills and spills. So it's just been one crazy journey.
I like that. I think, oh, the light's gone off. We were worried about that happening. Did you want to nip and turn it back on quickly, and we'll just summarize the last question? So just for those listening, at the start of the podcast, we spoke about how Rob has an eco light in his office where it turns off after 20 minutes or so, and we almost got through the whole podcast without it.
I obviously wasn't waving my hands around enough. That's something my sister teases me about. I need to wave my hands around less, and that means the light goes off.
Well, you can report back now and say, you know, it went off. So thank you so much for taking the time to join us and have a cuppa today. Before we go, is there anything you would like to plug, a website, Twitter, anything like that?
I think, for anyone who's listening, starting their career, the resource I really would recommend is The Conversation. It's an online magazine that does all sorts of topical stories across the full breadth of social and environmental and political science. And it's pitched in a way that's very accessible, and it would it opens my mind to all the possibilities that can come from a career in research. So I'd really recommend that.
Fabulous. Well, there you go, The Conversation. There's your plug. So thank you so much for taking the time. Absolutely had the best time talking to you. So thank you so much, Rob.
Yeah, thanks very much, Meg.
Thank you all for listening or watching Cuppa with a Scientist. We hope you found it interesting and will join us again. Do leave a comment and get in touch. I'd love to hear your feedback and thoughts on who you'd like to see on the show next. And make sure you don't miss a show by subscribing on Apple Podcasts, Spotify, and all of the mainstream podcast platforms. You can also subscribe to the Loughborough University YouTube channel if you prefer to watch the show. We hope you'll be back for more hot tea and even hotter stories to help you on your way to becoming a scientist.